Okay, well, good morning, everyone. My name is Kenia Carrillo, and I will present the first results of my research, my PhD thesis. That is the effect of the type of solvent on of the extraction of antioxidant compounds from Opuntia ficus-indica. And I'm from Mexico, exactly for the Autonomous University of Nuevo. So this is a little bit of the content we will be reviewing. And first, I want to introduce that, well, we currently live on a planet where natural common resources can be limited or by their consumption or by their use. So on the top of that, we have been facing problems such as climate change, ecosystem and soil degradation, as well as population growth. So therefore, among others. So therefore, it is crucial to explore new ways of consuming and producing these resources that are environmental sustainable and that are respectful for the environment as well. So one of these approaches that holds promise of addressing these issues is the concept of circular bioeconomy. And in order for bioeconomy or bioenergy to make a real difference to global climate change, a new source of biomass is needed. So, however, it must not compete with food consumption or have a significant negative impact on natural ecosystems. Therefore, this new biomass source should be cultivated on land where there is minimal ecological or economic competition. So, where are the only places available throughout the world? There are arid and semi-arid regions, which is a big percentage of the earth. So now, which kind of crop can be grown easily on these arid environments? And that is cactus. And one of the proposals that Mexico can give us is Opuntia ficus-indica, or usually known in Mexico as nopal, and in other words, prickly pear or chumbera. It is one of Mexico's most emblematic symbols of identity. So also this is a crassulacean acid metabolite plant that can adapt to grow in arid climate and soils with low fertility. Also, its water uptake is efficient and is high in fiber and other bioactive compounds. So, also the literature says that scientific production trends with Opuntia in the last 10 years are usually functional properties, biological activities, and the active ingredients that contains nopal. Excuse me. So there are antioxidants, phenolics, all the extracts, mucilage, polysaccharides, flavonoids, and betalains. So there is need to extract these compounds. And well, as background for the extraction of these phenolic compounds, we have found that most of the papers use methanol, ethanol, acetone, and water as solvents in a solid to liquid ratio for 1 to 10 grams per milliliter. And the extraction was made at ambient temperature. So the main objective of this first step of the thesis is to determine the best extraction conditions to maximize the obtention of phenolic compounds from Opuntia ficus-indica as a first step to valorize the whole plant. So, well, the methodology, first we cut the Opuntia cladodes. The cladodes are the leaves, these oval leaves. They were cut and liquefied and dried at 60 degrees Celsius for 24 hours, and then sieved to a particle size to approximately 200 micrometers. Then, well, the Opuntia biomass was extracted with a solvent at the biomass to solvent ratio of 1 to 10, and it was extraction by maceration. So the extraction was carried out for 1 hour and to 25 degrees Celsius and an orbital agitation. So then the supernatant, well, it was centrifuged, and then the supernatant was recovered for the characterization. So the characterization was made by total phenolic compounds, reducing sugars, and the DPPH scavenging activity, as well as ABTS. So also the design variables that we wanted to evaluate were the acetone, methanol, ethanol as solvents, as organic solvents, and then their solvent concentration. So the results for first the extract characterization. Well, the sample extracted was the best sample extracted was with 50% methanol, as it had the highest total phenolic compound concentration. Nevertheless, the extract with 50% acetone had the highest DPPH and ABTS radical scavenging activity. However, in numbers and in a table, it doesn't look really distinguishable. So next we will see the main effects that were evaluated. And so we can see the right that there are difference in the color of the extraction. Well, the solvent is less concentrated. And this is probably because chlorophylls are being extracted as well. And well, phenolics and other interesting compounds, biocompounds. So these are the results of the effect of an organic solvent. As we can see in the graphs, there is no significant difference between the solvents. However, this is slightly better results with methanol. And we see it also in the table that DPPH and ABTS scavenging activity is really kind of different, and we will see in the other slide. So this is the effect of solvent concentration, and we can see that the less concentrated the solvent is, the higher concentration of phenolics compounds, and the higher the antioxidant activity were. Yes, in this case, this can be because of the we extracted possibly glycosylated flavonoids, and this is because the DPPH and ABTS reaction media is quite different. One is in methanol, another is in water. So probably the compounds that were evaluated in the DPPH are only soluble, well, in methanol, and in the ABTS scavenging activity were compounds dissolved in water. So we can see that maybe the compounds that were the highest antioxidant activity were the ones that were dissolved in water. So, well, what are the antioxidants? Just to discuss a little bit. As the word says, well, it prevents the oxidation of biological molecules such as lipid, proteins, nucleic acids, in order to prevent degenerative diseases. These are phenolic compounds and usually found in plants as secondary plant metabolites. And in nopal, there is quercetin and picoumaric acid as main of the flavonoids that are present. And we couldn't corroborate this by HPLC and other separation of the extract, but this is a possibility that these compounds can be present in the form of glycosylated flavonoids, which consists as a flavonoid and a sugar attached to that flavonoid. So it can be present in the aqueous fraction of the extract, and they are more soluble in water and could give us a higher antioxidant activity as well. So the conclusions that we found the best extraction conditions for Opuntia ficus-indica that were 50% methanol, leading to 12.92 milligrams of gallic acid equivalent per gram, at the ppH of 30%, scavenging activity, and 95% of scavenging activity of IBTS, and 9.22 grams of dextrose equivalent per liter. However, we need to improve the obtention of these different products as a successive extraction could be performed. As well, we can obtain pigments with acetone, flavonoids and phenolic acid with methanol at 80 to 50%, and other valuable compounds that could be extracted with water. Well, the perspectives of this work is that this is a first crucial step to develop a better biorefinery model where important products such as antioxidant compounds, pigments, methane, hydrogen, and biocarbon can be obtained from the valorization of this Opuntia ficus-indica or nopal. And this is my reference, and thank you very much for your attention.